I want to just talk about these three things because I want you to pretend like you're having Sunday dinner with whoever sits at your Sunday dinner table. And I want you to imagine that person turning to you and saying, cool, what are you doing in math these days? And you say, oh, I'm studying trigonometric ratios. And that person going, wow, that's a fancy word. Tell me more. What would you say about trigonometric ratios?
I would just tell them about the sum hippie thing.
All right, and what are the sine, cosine, and tangents? What are they? What are they? They are ratios. Are ratios of what? It's the ratio of side lengths for triangles. What kind of triangles? Right triangles with a common angle measurement. If I have two matching angle measurements, I have what kind of triangles? If two triangles have two congruent sets of angles, what kind of triangles do I have? Similar, say it out loud. Similar, right triangles. So what they are trigonometric ratios are unit ratios. Remember we talked about buying yogurt? The unit ratios for similar right triangles. And I can use these unit ratios as scale factors to help me solve. So in a right triangle, I'm talking about similarity through angle-angle similarity. Mathematicians went through and did those measurements for a 1 degree, a 2 degree, a 3 degree, a 4 degree, a 5 degree, 6 degree, 7 degree, and on and on and on. Those unit ratios I can use finding my sine, cosine, and tangent relationships. And I'm going to solve for my side lengths or my angle measures. I like writing the trigonometric ratios like this because I think it matters to know which is being compared to what. The sine is the opposite to hypotenuse. The cosine is adjacent to hypotenuse. The tangent is opposite to adjacent. And I need to make sure that I'm keeping track of which angle is my theta, because my opposite and adjacent depend on what angle is my theta. Your hypotenuse is always your hypotenuse. So if you're having a hard time telling the difference between your side lengths and your hypotenuse, you can get one of the red pencils. You color it out. Hey, join me. If you're busy doing something else or looking at something else, you're missing out on the conversation and the opportunity to ask questions. So if you're busy checking homework, hold on to that. I'll give you plenty of time for that. I want you to come back, and I want you to be with me. One of the most confusing things that kids find is the fact that there's more than one theta. How would you explain that to them? How would you explain why there's more than one theta? What would you say?
Depends on whichever one you want, doesn't really matter.
How many thetas are there?
2.
Why not 3?
Because the third is the right angle.
Yeah, because that third one is my right angle. So he's always going to be 90 degrees. Same as he's always 90 degrees. This is always my hypotenuse. My theta can be here. My theta can be here. And that's what drives which side is my opposite and which is my hypotenuse. Hey, when I ask you to solve the right triangle, what am I talking about?
3 side lengths and 3 angle measures.
Now, usually at least 3 of those pieces of information are given to you. So 6 total pieces of information, but you'll have a combination. If you have 2 sides, go ahead and use Pythagoras if you want. If 2 of those pieces of information are triangle measures, go ahead and use your triangle sum theorem. So your trig values are going to be what it is you can't solve using what you already know. Last class, this next question was the hardest one on the worksheet. I got more questions on this one. Kids didn't know how to do it, and it's the easiest one. How come? What are we doing to solve it? What are we doing? Everybody take your calculators with me, please. Go ahead, turn them on. Would you please hit clear? Would you please second mem 7, 1, 2. Clear everything out so your calculator looks like this. You are using a shared resource, so the very smart thing to do would make it so that you clean it out directly. For those of you who missed that and I went too fast, second plus sign is my memory. My choices are 7 to reset, 1 all RAM, 2 resets. Second mem 712. Say it out loud. Second mem 712. Say it. Second mem 712. Now that I'm dealing with trig ratios and I just cleared my calculator, what's the most important thing for me to do? I need to go to my mode. That's this button here next to my second function. And I need to change it from radians to degrees. When you get to pre-calculus, you'll measure the distance around a circle in terms of pi. That's radians. This here in geometry, we're sticking with degrees. Arrow over, press enter to switch the highlighting from radians to degrees. Check in with your partner and make sure that they have done this with us. Go. All right. So when it's time to find this cosine, use your calculator to approximate. I'm asking for the cosine of this degree angle. That's the scale factor. That's the trig function. That's the ratio between my adjacent and hypotenuse of a right triangle. If I were to compare my adjacent side value and my hypotenuse side value, and I wrote it in a fraction and I divided, I would get the scale factor, and it would be 0.5299. That is the scale factor, that is my cosine, that is my unit ratio for that 58-degree right triangle. Rule of thumb, we're going to round trig ratios to 4 decimal places. What's the difference between 4 and 5? Talk to me about that. What's the difference?
To solve for that one, you have to use n -1.
Yeah, this is your inverse function. So here is my straightforward function using these buttons on the calculator. But when I'm dealing with this one, I don't know what angle A is. So I need to know the inverse of this value. And that's going to give me my measure of angle A. So I'm going to go ahead and say, what is the inverse value? What angle measure has a tangent value of 1.2386? And that's going to tell me, hey, that's a 51-degree angle. So 51 degrees has that tangent value when I compare my opposite over my adjacent in a right triangle. All right, so if you take a look at 6 and 7 and 8 and 9, 2 of these problems have you solving for angles, 2 of you having you solving for side lengths. Check in with your group and identify which are sides and which are angles. Go. Six and 7 have you solving for what? Stick with me. 6 and 7 have you solving for your angle. Angle B in 6, angle T in 7. 8 and 9 have you solving for side lengths. Here I'm solving for my opposite of this theta measurement, or my hypotenuse, and again my opposite and my hypotenuse of this theta. Would you and your group mates please have a conversation about solving for each of these on your mark and set, go. So here's the deal. When you're solving for theta, it's asking me for B. I can solve for A, I can solve for B. Once I get one of them, I use my triangle sum theorem to get my other one, because they're going to be complementary angles, right? Their sum's going to be 90 degrees. So here's the deal. I used tangent. Serena and I just used sine. Alexandra could have used cosine. Why does it not matter whether I use sine, cosine, or tangent? Why can we use any one of those three? How come?
You're given all the side numbers.
Yeah, so we're given each side length. I have for this theta, my opposite, I have my adjacent, and I have my hypotenuse. Last class said we didn't do anything that involved hypotenuse because we didn't like that radical. So that's why they went with tangent. How many of you chose tangent because you didn't like the radical? I'm okay with that. Avoid the radical if you can. Sure. Absolutely. I think of sine, cosine, and tangent as three siblings, maybe three brothers of the same family. Anybody know that family that names their kids some kind of weird and offbeat name, right? So here are the three kids, sine, cosine, tangent. They'll be glad to help you out with whatever you need. If your problem involves your opposite and your hypotenuse, call sine. If your problem involves your adjacent and hypotenuse, cosine is the one that you want to work with. What if I call tangent? What is it that I'm working with? Your opposite and your adjacent. So each of those ratios are different combinations of proportions or fractions I can make using my side lengths. Questions on how to solve for B and how to solve for the measure of angle T. Anybody want me to go over it? Anybody not understand it? Ask me a question, pretty please with sugar on top. Go.
This is just like kind of a question in general.
Go.
But if we're doing it through the calculator, so if I do, sine of something, it's gonna give me like a really long number. Is it okay if we're doing, if we're plugging in the calculator, can I just do second answer to be that value, or do I have to round it? Because if it's like 1% off or
No,
something,
second
we
answer is
round it.
fine.
Okay.
You can kind of substitute that value in. If you'll notice, especially when we get down to these other ones, that's why we end up leaving our answers as whole values and then entering them into the calculator, so we only round that one final time. All right. When we're solving for x and y, we're given our theta. And then we have to choose which ratio has what we need. If you look at here, my theta is 19 degrees. She has an adjacent side of 15. I'm solving for my hypotenuse. I'm solving for my opposite. I'm going to be using tangent and cosine to solve for each of these. When I'm looking at number 9, I have 38 degrees. That's my theta. I have my adjacent side. So again, it's cosine and tangent that I'm going to care the most about. And then I can set up my story, solve for my x, and then when I type this in, that's that big long decimal, that unit ratio, that scale factor, that I then multiply it by. In each one of these, as you're solving, a couple things should be true. Number one, you should always be checking back and seeing if this makes sense. So let's just talk about number 8 for a minute. If I have a side length of 15, an opposite side of 5.16, and a hypotenuse of 15.86, does that make sense for my triangle? And go back to those triangle properties that we learned before. Smallest side, opposite smallest angle. So far, so good. Hypotenuse should be my largest number. Yep, that checks out. So when I go to solve here, I'm solving my proportion, cosine times y, cosine 19 times y is equal to 15, dividing each side and getting that value. Would you and your group mates talk through 8, and I want you to work on solving 9 as if your life depended on it. I want to make sure that when you solve number 9, your answers are perfect. On your mark, get set, talk. He's half of his life sure he got this one right. We'll have to let Owen's mom know whether we saved his life or not. All right, ready? Here it is. 38 is my theta. When I go to solve for x, that's going to be a tangent relationship. Opposite compared to theta. My opposite is my unknown. My adjacent is what I know. And I go ahead and I use my cross products. X is equal to 14 times the tangent of 38. That's what I enter into the calculator. If you're just watching and not actually pressing the buttons, it's too hard for you to remember what to do. If you don't do it, then you have no muscle memory. When I go to solve for y, my unknown is in the denominator because the cosine of 38 is going to be my adjacent compared to my hypotenuse. Well, my hypotenuse value is my unknown. My y is in the denominator. Sammy brings up a great shortcut. He says, can I exchange these two? Would you have told him yes or no?
Yes.
How come?
Yeah.
Because of the theorem thing. Because they're extremes. One of our proportion properties that we learned is if you want to exchange your extremes, you're allowed to because ultimately you still get the same cross products. So if I flip-flop y and the cosine of 38, now my y is out of my denominator, and I get to enter in 14 times the cosine of 38. Here's the deal. If that's the 40th or 50th one of these that you've done, you're like, no problem, I get it. If that's the third or fourth that you've done, you're like, oh, it's dicey, that's confusing to me. So if you've skipped out on the practice that everybody else has had, that's why you're having a harder time. With practice comes two things. Speed, you can do it faster because it's not your first time through. And accuracy, you can take a look and you're not going to make those mistakes. You gotta do this, you gotta practice. It's all at hand.
You said multiply, you divide, right? It's
You divide, so 14 divided by the cosine of 38. Are we good? Would you please check in with your group mates, and would you please talk about these three types of problems? Solving for sides, solving for angles, writing trig ratios, and say which ones you think are the trickiest, and you mark as that talk.
Like realize that.
Like process.
All right, come back.
I can do that.
Flip over your warm-up, and there is the key to what you had for homework last night. Take out your completed homework, please, and compare your work with mine. In numbers 1, 2, and 3, we asked you to write the ratios. Kids were telling me they thought that was really confusing. Well, now maybe just that processing of what do you mean write the ratios? I want you to write the sine, the cosine, and the tangent if you have all of the side lengths. Write me a ratio opposite to hypotenuse. Write me a ratio of adjacent to hypotenuse. Write me a ratio of opposite to adjacent. Notice for these ratios we had some simplifying that we had to do. So this one here, this cosine of x should have gone to root 3 over 2. My sine of x was 1/2. My tangent was root 3 over 3. Here on each of these I simplified. Take a look at 4 and 5. Now I'm finding the value of x. I'm given a angle measurement, and I have to look at which two sides of my triangle is the story about. In number 4, it's about my opposite and hypotenuse, which is why I'm talking about the sine. In number 5, it's my adjacent and hypotenuse, that's why I'm dealing with the cosine. In number 6, it's my opposite and adjacent, that's why I'm dealing with my tangent. Same as in 7. If you find yourself getting confused about which side's which, do yourself a favor and go ahead and mark the hypotenuse, which is your side opposite your right angle every time. Your opposite and adjacent switches according to your angle measurements. Your hypotenuse is always your hypotenuse. Questions on 4, 5, 6, and 7? When you look at 8 and 9, drawing a picture will help you every single time. We're dealing with right triangles. Every single one of these problems is going to have a right triangle. Find the vertical, find the horizontal, find the diagonal distance, find the angle measure. When you go to draw these pictures, if you have in your head that it's got to be a right triangle somehow, that makes it easier for you to draw those pictures. Questions on 8 and 9? Yeah.
It says round to the nearest foot, but you put 14.31. So
Yeah.
on the test, if we were to just round to the nearest foot, would we get
14 feet.
Okay.
Same thing here. If you'll notice, this is different on your key that I gave you. Last class we switched it because it said to the nearest inch. So I changed this 12 to 144, and that gave me my answers in inches. So I rounded to the nearest inch.
So it doesn't say round to the nearest inch or anything like that, you just go to 4 digits.
2 for side length.
Okay.
But it doesn't from 4, 5, 6, or 7. Does it say to the nearest 10?
It does for these homework, for this particular homework, and we like hundredths better. If you're ever curious on a quiz or something where the grading counts, you can ask. I'll be glad to clarify for you. Okay? All right, flip over on the back. The front has you finding side lengths, the back has you finding angles. So the 56-degree angle, 63-degree angle, 57-degree angle, and 22-degree angle. Any questions on 11, 12, 13, or 14? 15, I'm okay if you skipped it. It was about a rhombus, and you haven't learned about them yet. So unless you just naturally know all about rhombuses, you probably didn't know that the diagonals are perpendicular and bisect each other. It's okay. 16 and 17, we ended up, so 16 was confusing because I ended up solving for this A, this adjacent side, and then I went ahead and I subtracted this distance W from it to find X. And I knew that W was 5.5 because it was a 45, 45, 90 isosceles right triangle. 17 was a mess. For some reason, I ended up using cosine instead of sine, which was my mistake. So this is updated and fixed. Your keys are wrong. Your keys have different answers on them. And then we have 2 more word problems. The ramp on the back of a moving van and a tent. And again, the same conversation applies. We're always about making a right triangle. So you're going to be looking for what is my vertical distance, what is my horizontal distance. If they talk about the length of the rope, that represents that diagonal. Questions on the homework? All right, so I'm going to ask you to put your homeworks and your warm-ups aside, clear your desks. We're going to do another round of practicing. So here's a game board that you can put on the basket. If you are in quadrant 1, will you please get whiteboards for your group? If you are in quadrant 2, can you get markers and blocks for your group? If you are in quadrant 3, would you please come to the back and see me for dice and cards?
Sure. Then again, you're arming on the desk.
You got some crap on your
All right, so before you start, let's take a look at side A. Side A directions say the following.
Keep all the markers. They're all mine. Keep all the markers.
So let's go, come back. Are you with me? Side A says roll the dice and draw 2 cards. Draw a third card if the first 2 are the same value. If you roll a 1, 2, or a 3, you're solving for the measure of angle A. If you roll a 4, 5, or 6, you're solving for the measure of angle B. Your first card drawn is A. Second card drawn is B. Why do you think we had to say the card with the greater value is C in 2 and 3 and 5 and 6? How come?
Use the hypothesis.
Woohoo! Check out your triangle. C is your hypotenuse and has to be the biggest value. So whether you're drawing for A, solving for theta being a B, or theta being A depends on your dice roll. On side A, you are solving for theta. Flip over and take a look at side B. On side B, you are given which angle is theta. You're going to roll the dice, draw 2 cards. Here's something tricky. Multiply your first card by 6 for the measure of theta. So the first card represents your angle measure. The second card is going to represent A, B, C, or D. Question for you. If my aces are 1, 2 through 10 are face value, jacks are 11, queens are 12, kings are 13. Why did we do multiply by 6?
Because the highest number that you can go without it going above 90.
So do not jokers.
Yeah. So if you get a joker, it's a bust. Or we should do jokers of 14. Does 14 take you over 90?
Below 90.
14 times 6 is below 90, right?
Yeah, we said
84.
15 times 6 is
Okay. So we should do jokers of 14. All right. You only have about 10 minutes to play, so make the most of your time. And your markers set go.